Okay. Can you see my screen?
Yes, we can.
Okay, perfect. So I believe this is one specific tab. So this is just a website. Part of the things I'll be doing today, show you how you can certify your project, which is very important as part of the OSHA strategy. Another thing I will be sharing with you would be one of the very important projects I currently worked on at MIT that it's also open source. How did we get into putting it out there for people to use? How did we kind of documented everything in a proper way that if you see the file or the GitHub or the link to the document, you can always recreate the same thing without reaching out to anyone, basically. Which is very important as part of open source community, that you don't need to send an email to someone and say, hey, I want to recreate this product or this hardware design. You can always just go online and just download all the file, including the firmware, the 3D printing files, and the tools in order to build your own solution as well. So starting off with the first part of this presentation, which is the OSHA. Again, OSHA is a platform. I think it started initially with conferences. How can we bring open source hardware community together to present their work, to interact? And then later on, it has grown to be a platform whereby products can be certified. So you have an hardware design, you've created a very fantastic innovation, and then you decide to put it out there, get a certification. And getting a certification is just getting a number attached to it, getting a license attached to it, and following the proper procedure to make an online platform or whatever design you've made completely accessible and in a very open way. So I'm going to go one after the other. So the first thing I have to do here is to simple way. Let's say we want to certify a project. I just click on this. So let me move my screen away from here briefly so you can see. So you've come up with this fantastic invention, and then you want to put it out there for people to kind of build. But again, you need to give it a name. You need to give it the license code and procedures you have to follow. So within OSHA, we've created this platform to give any hardware developer or even 3D printing processes method they could use in order to get their products well documented and alongside certified, within the OSHA platform. So the first procedure is, filling all this information, the kind of certification method, if it's just individual. You put in your name, the country, for now, I think we have one single country from Egypt, let's say in Africa, basically, which is really cool. And they just joined I think maybe 2 years ago. Someone published a well-documented, products within the OSHA platform. So you put in all these details, and then you go to the session 2, which is basically putting in names and description of the products you just launched or you just built. If there's a website, most of these websites, people usually use the GitHub platform. They just add the GitHub link to this place. So this would also kind of categorize the product if it's going to be IoT design, if it's focused on environmental monitoring device, or it's more on the manufacturing design. And then you can go ahead and select some of the project type. For example, it could be 3D printing is part of it. There's IoT, or there's science, design. Maybe it has to do with chemistry or something like that. What are the keywords that when people type it within the normal web platform, what will they see? For example, if you build something around smart home automation. So home automation could be part of the keywords here. Yeah. And then where can the documentation be found for the project? So again, it could also be GitHub. So following this procedure, I think one of the things I find interesting is, it's a two category of license. For example, you have the hardware and also you have the software, depending if your device is IoT based, and then you have a firmware that needs to be programmed within the hardware. And the firmware is always categorized as software sometimes, depending on which method of programming you've used. So yeah, if it's hardware, you have to read about. Most people usually use TAP, and some people TAPR. Some people decide to choose the SERN as a license for hardware. So this potentially depends on the hardware specification, if you want it to be within this licensing environment. Some people use the MIT license for everything, including the software, the hardware. You just publicly making it available for people to use and download and kind of create their own products. So I run through this. You follow all this procedure and ask questions like this, and the project license modification, yes or no, and then you click most of this agreement and terms. Write a more brief explanation about if you agree with the terms and condition, and then you just submit. So this is the most easiest way within the OSHA platform that you can get your product certified. And getting it certified could take mostly 2 weeks. It's really, really open. There's no one person that kind of sit on the table and say, yes, we're going to accept this product, or no. It's a group and collaborative method we usually follow before we can kind of accept this product into the OSHA platform. Once you wait within 2 weeks, the good thing is within that 2 weeks, if it's going to be rejected, they will still reach out to the developer or the designer and say, hey, these are one of the reasons why we couldn't, pull this product or this design into the OSHA certification category because it's not well documented, or it's not properly, maybe you saw some things, you didn't reference some of these people. You use some code within Spark for the environments, but you never kind of reference them and say, oh, you use their libraries for something, and then OSHA will just send all this information back to you, and then you just rectify it. But I'm pretty sure that if the product or the design is well documented, it's going to be acceptable within OSHA. So once it's accepted, it's going to be part of this all like other products within OSHA. Let me see if people can still hear me. Okay. Can you hear me? I just want to be sure that I am following the right procedure. Yes. Okay. Thanks. Okay. So these are the products that are well documented, follow the right procedures. If you go on the internet, you can kind of recreate the same thing. It's publicly accessible. It's like a very fantastic product as well. So if the product is accepted and it's within these hardware projects, one of the unique things that you see within all these projects is that it has UID, which is like a very specific number dedicated to the product itself. So if you click on, let's say, for example, we click on this, which is like a 48-key MID controller using I2C. If you look at the web link here, which is the HTML page, you see it added the UID code here as well. So if you have your own personal website, you can always copy these and just put it into your personal website to give people access to the OSHA directory. OSHA also, we usually put it on Twitter to kind of make your products accessible to the world. We have like 20-something thousand followers in one of the OSHA Twitter accounts, and people can see that, oh, so person from Italy just, certify his or her products, and then it's MIT software license. The hardware is CERN, and then the documentation is CC BY 4.0. So with this, it gives you some sort of publicity as well about your products. If you, for example, I'm still going to talk about how can you market some of your open hardware, because it's always the question that come after all this discussion and say, you certify your product, good, you documented it, fine, it's online, but what can you get as benefits, as part of you putting this product to the world to use, basically. So going back to when it got certified, you can see the project website here. It looks like it's someone's personal link. Let me see if it's going to open up. It's like it's personal, his own personal page, but most people, yeah, you can see he kind of link it to some sort of hardware. Yeah, and then another best description about the products, again, still showing the Oshua logo as well. So going forward, yeah, as I said from the beginning, when you get your product certified, you have to select the type, and you can see it's also showing when the product got certified. The person can download this picture and put it on their website. Like, if you have your own personal website, you can add this as a trademark that you've already trademarked your design with this UID from Oshua. So this is more like the procedure open source hardware usually follow to get your product certified. And then after the certification, we also have like a very unique method like API call. Basically, if you want to read and write using some sort of API plugin, we also added the API within the Oshua certification program. You can read, write directly to your certification platform, basically. This is also very like a tool that comes handy for developers that want to play around with their design documentation procedures as well. So that's one of the very basic about the Oshua certification. I can also kind of go through some of the processes. For example, you want to get your product certified, you get it certified. You can also read more detail about what are the requirements before getting it certified, actually. Like, for example, if you have to read about the software, you can read about what are the spectrum for the software, what are the licensing tools for the software. And then if you want to go back to hardware, it gives you what are the spectrum for the hardware and also the licensing for the hardware. For the spectrum, it's always like this process of, you follow through this process to reach the last stage for the hardware. And then you kind of do the licensing. These are more of the general method people use for licensing for hardware, basically. And for the branding, this is also very important. Like, you have your design. Sorry, I'm going a little bit fast. I just want to wrap up some of the very important thing with Oshua certification. And, because if you have a product and you want to get it like a proper license within the Oshua environment, it's really important to see some of this process as well. Another thing that I've realized as part of what happened when people get their product certified, someone could just go on the internet and just copy someone else's work, and the work is also within the Oshua platform. What happened? These are questions that is part of the FAQ that we usually answer. What happened when a product was already certified before and you are coming with the same similar design? So we usually reach out to the person that designed the product, like the first designer or developer that kind of published within Oshua, and say, hey, someone did a similar without any reference. What do you think we should do? Do we kind of, we usually find the balance between two. We ignore some of the messages, because if the other person is trying to certify a already certified product, we don't accept it, because we feel like you just copy and paste this product. Or someone just kind of redesign what SparkFun already designed without removing any components, and you want to certify that. We usually go against that. Either you just use platform SparkFun design and add it to your own hardware. SparkFun is so open to that. It's always a product that everyone used to kind of add on to their own development. It's a plug and play kind of design. You can always source it. And for example, you need a breakout board quickly. You just buy it and you get your whole prototype like in a day, basically. And that's what SparkFun is all known about. So going back to part of the branding, as I said, we we kind of brand some of the work and put it on Twitter, put it, sometimes we even put it on the website and say, this is a very well documented design that people should look out for. So yeah. Part of other, I also added this as what are the things that people usually ask, why did OSHA create certification? What does this certification do? Can I use non-open components in my hardware? You know, these are questions that it's publicly on the internet as well that you can read about in order to get more insights about the OSHA platform. What else do I need to? Yeah, so pretty much these are things. And again, maybe after this call, you have like a specific product that you've worked on in the past, and then you kind of documented it somewhere within maybe your GitHub page, and it's hardware, and you never kind of put it on OSHA or certification platform. I think this is the right time for you to think about that and say, you want to put it out there for people to see, read, because it's well documented. You don't want to just, keep it to yourself. One of the things I've realized about open source that I really enjoy a lot is that we took so much from the internet. Like you go online, GitHub, you search, what is the library for this? So when taking too much from the internet, we should be able to give back to this internet. I really wish at some point there won't be anything out there again that we can access, but it will be nice when you build something, you access it from the internet, you modify it, you added more features, you added some very fantastic innovation. Just push it out there for people to also learn from your skills and also learn from some of the creativity that you have, which is also part of the things we preach within OSHA as well. So that is it with certifying your products. I'm going to close that. So selling your products, which is also very important in the African context, because we spend so much time, energy, money, resources. We borrow money to build prototype. We ask our dad and say, hey, dad, can I get 20 bucks? I want to buy 5 resistors. Can I get this? But I want to buy GPS, GSM. This is really cool. But if you build a very innovative solution and you want to kind of sell the open source product, this Tindy is also a very good platform where you can start selling your open source hardware. There are a lot of components within the platform that people usually kind of put out there. You can follow all the normal procedure on how you can get your product within Tindy and then get it in the market space and people can place an order. It will be so funny, like when you design the product in Ghana or you design the product in Nigeria, and then someone in the US place an order and you have to ship from Nigeria. This is fantastic news I want to see. Publicly, where people design their products, put it out there. It's open, people can download the file online. One of the things SparkFun has done is that it kind of kickstarts, it makes the production time faster, because you can go on SparkFun, download it, buy the components and start building. And for you to spend the time to start designing the circuit from scratch, it could take longer time. SparkFun make it more faster. These are things that you can also kind of make it more comfortable and convenient for hardware developers when you kind of sell it and then still make a little bit of money out of it. But again, still using the method of open source, because if you look at this, they did a video, there's a documentation, it shows all the list of the materials that you can use to build it if you have the time, basically. So yeah, they have different kind of platform, like DIY electronics, 3D camera, for smart design. Let's see, someone sending a message. I need to be sure. Okay. All right, so that is it about Tindy. There's also Crowd Supply. These are platforms that some of you might be familiar with before now. Crowd Supply is also like a platform where you don't have all the investment. Hardware is always the hardest. If you're able to raise money, it could be the next $1 trillion company like Apple. But the process of reaching that stage, you have to extensively keep developing your products. Crowd supply is a platform where you can potentially put just 2 or 3 prototypes out there. People would, you know, kind of put money into it and say, we love this product. Let's make it come to life. Let's support this product. The product is not publicly available. It could be available online, but you can produce 1,000. You can produce 20,000. You need crowd support in order to do it. It's just like Kickstarter, but Kickstarter for hardware and open source developer basically. So it's also very open. You can apply. You can put your product out there. It's usually go through like procedures whereby what is the product itself, which category they have to put it, and then people can kind of pay. You can put a price tag, just like Kickstarter, into this open source hardware where people can place an order and just buy it and and support your design basically. So crowd supply is also a very good platform in order to make money from your open source hardware design. There's also group gets, which is also a very, yesterday I was looking at this products. They say it's active. Let me see, view campaign. So this is also like a crowd supply, but people fund the hardware. If it's well funded, that means you're gonna take this product to the next level, meaning you can produce like 50 units, do the design, send it to China, or you can do your own production within whichever. If you're very good with SMD soldering, you can always place the components yourself and just ship all the 500 units to all the backers basically. So Group Get is also a very good platform. One of the interesting things that I want to also share today is that if at some point you have difficulties with, for example, Group Get or Crowd Supply or Tindy, Oshwa would be super happy to kind of get in touch with whoever is in charge of it. As a platform, we have we have like different. They also even support some of the Oshwa program that we usually have. For example, the Oshwa Summit, the open source like hardware summit. The recent one was in New York. So all these other platforms usually supports the summit. So we'll be so happy to keep you in touch with them in order to get your product out there if you have questions. I know there's always going to be questions about, can this be shipped to Nigeria? Can this be shipped out from Nigeria or out from Ghana or out from Zambia or something? What are the procedures for shipping method? Do they need to do some background check? Because these are problems we face with Kickstarter, that sometimes it's difficult to set up a Kickstarter if you are in some specific country in Africa. So you have to be somewhere outside some specific country before you can get it into Kickstarter. It's always about, they don't have anyone on ground that could do the verification of the products or do some background check about the person that is designing the hardware or the product itself. So that is that about the group gets. I'm going to talk about, if you have questions, you can put it in the chat. I'm going to talk about one of my latest like products, like open source projects basically, which is also a very standardized ways of writing and designing or putting documentation together for open source products. And it's also publicly accessible. Yeah. Sorry. Yeah. So basically, this is one of the projects I'm working on, which it looks like it's done. I have like the board here as well. Let me see. Yeah, it looks like high grade industrial standard. But basically, the reason for the design is that environmental sensor, it's always stationary. People design sensors, like install it outside with solar panel. For us, we've moved outside that. We want to capture environmental data block by block, basically on top of vehicle. So we put this device on top of a moving vehicle, and as the vehicle move across the city, we buffer and get data sometimes every 5 seconds, just within range of, as long as the vehicle is moving. So we created a website for it, whereby it is also well documented. Just the website alone is well documented. But we have a GitHub open page where anyone can build it. We even got like some pictures yesterday from Italy. Someone just, redesigned the old product from scratch. So one of the goal when I joined this project was, how can we make these accessible to everyone, for anyone, local community in Africa, or local community in Asia, or any part of the world, basically. So this is just like some sort of like pictures to show how the old 3D kind of connect together, and then you keep building it like that with solar panel, and then with magnets on that. The magnet it's the attachment that we use to, when you put it on top of vehicle, it doesn't move at all. It's a very, very strong magnetic surface, basically. So we have the electronics inside. It's just showing how beautiful it looks in the design. We have all the gas sensor and also the OPC as well. Yeah. So these three taglines shows the open platform, how we make this whole design completely open. If you click on each of these, you can access it directly on the GitHub. So for example, you want to know about the overview of the design, the hardware, the firmware, the fabrication. So you want to do your fabrication. We have a 3D printer, you just want to print all the parts. You can use the fabrication handbook. So after building, if anyone is familiar with environmental scientists, environmental data collection, there's always a need to do some calibration. Calibration is just a process whereby you're using a low-cost sensor, and then you want to compare the low-cost sensor to much more high-grade sensor. You want to be sure that whatever data you're getting from the low-cost sensor, it's comparably reasonable to what is out there with high-grade sensor. So we usually do some sort of calibration model whereby we put the low-cost sensor close to the high-grade sensor for like 3 months. And then we run some machine learning model to kind of triangulate the results. And then the outcome is always really plus or minus almost accurate, basically, using low-cost sensor as well. So we added all the data sets we use for the machine learning model as well. So the learn, as part of making it interactive, we implemented some sort of coding exercise. So for example, you build something, you have the firmware, the device is working, you've done the calibration, you have the data, and then you want to explore, you want to understand your cities, because each of the data we collect, there's a GPS. So for example, if the vehicle is moving across, like, let's say your village, you want to be able to explore what is the environmental situation within your community. So we've used the coding exercise to kind of give you insight about the pollution rate within your community. And then there's a facilitator handbook. So for example, if you want to also teach students how to do this coding process as well. So all these are all part of the GitHub platform. And so the product has been, running for several years, but within this platform, we call it platform because it's flat. I think the name is just very funny, but because it's very flat products, we call it flat. Before making it flatborn, it's always been white born, black born, different name, and everything is still city scanner. So we've deployed in different part of the world. As you can see, like we've got in Sparwood, Boston, obviously, and then New York. So we hopefully want to deploy in Lagos. I tried to do that in last year, December, but I was really catch up with a lot of activities. But I took the device, turn it on, get few data, but the goal is to just put it on top of one of the, we call it downfall. If anyone is from Nigeria, we have these yellow buses whereby usually go almost anywhere in Lagos. So we'll be deploying Beirut, Oskama, we have Tokyo. So these are kind of deployment side that we've had city scanner. So it moves from prototype in 2017. You can see like tube. We put all the tube together and then move to more like a very close industrial grade into like a little bit like at least perfect design in 2019. And then in 2020, 2022, it's similar to each other. And then we move to a completely flat with very minimal screws. If you look at this, we have like almost over 20 screws that you have to keep moving, screws everywhere. But this, it's really little. It's so easy to assemble. And then we have like team of people that worked on these. Yeah, pretty much. So that's part of the what I've been working on at some point. It's one of the projects I've been working on. So going back to the GitHub, I don't know if there's any question. Let me just check. Be sure. No, yet. Okay. So going back to the GitHub, I kind of took it upon myself to make sure that the GitHub is properly documented so that anyone can build the Flatbone. So again, going back to the website, you can go back to the website afterwards. We have the build, we have the hardware. The hardware has like the fabrication files, which is, if you access the fabrication file, you can just download, put it inside SD card or USB, plug it to your printer, you print. Although one of the printing could take 11 hours, another could take 5 hours, you can start printing. You can go ahead and get the hardware schematic, which is all the design for you to get a PCB out of it. Although it's very complex because we have a lot of components within the PCB. And one of the things we intend to do is how can we make it and reduce the components, because it's industrial grade. You can imagine if you have to design this within like just a normal, let's say you have all the components and you have to use SMD pick and place. It's a very tedious work, but we have the circuit design and also the bill of materials, or the components we've used in order to build this Flatbone. And then for the firmware, which I also kind of wrote, most of the, almost like 80% of the firmware, we added all the code. If you download the code, if you have one of the particle modem, if you flash it, it's going to start working immediately. We also have the fabrication, and which is very important to know. It's like a check mark to see, have you compiled, have you kind of followed the procedure we've created? That's, oh, you have the battery, check the voltage, you have the modem, is it flashed? Just to make sure that every procedure, including the 3D printing part of it as well. So the fabrication handbook is just more like a more detailed guide that give you all the information you need for the Flatbone. It's gonna afford, yeah. So I'm trying to see if I can download, but I'll just go through. So it gives you like, this is everything you need for the whole Flatbone, which is the CD scanner. It's a very typical example of a well-documented product that I worked on. And then it shows all the assembly tools. Even putting these to the internet shows that it is well documented. Not talking about the hardware where you have to program something. We don't necessarily need to show you how you have to keep writing your your coding platform and say, oh, you have to write some function here. You have to declare some variables here. We don't need to necessarily do that. But so far, if you can download and flash the device with the firmware, it shows that we've really kind of showcased, better approach within the code. So again, this shows all the process of putting everything together. You can always go down and show like a well description of how you can get the 3D printing, attach them together, and you have a final product. So I'm going to go back to the firmware, so which is also like a very important part of the design. For example, when we push the firmware house there, we show some very important information for users that want to recreate the same firmware or kind of modify the firmware as well. One of the things that I try to make sure, example, let me show like for the config file. We added some sort of TCP/IP here. If you remember TCP/IP, if you're familiar with internet protocols and all those things, we changed the IP address because the one we have for the deployed version of the products, we try to use our own specific IP address that kind of go to MIT server to log all the data. We always give this instruction that you need to change this IP address to your own, your own personal IP address. Okay, so so going back to the documentation again, you see the build and then the explore. In fact, part of being open, we added all the data set that we've been collecting since like 2019, so that if you're also building your own machine learning model, you can just build around that, because we have like a very high range of data set that we've been collecting for quite a while. So we have the coding exercise, which is also imported within the Jupyter notebook, where you can run your Python scripts. And when we added this, that everything is under MIT license, meaning you can copy, reuse, do whatever you want, modify. If you want to write a paper, you can cite us. You can do anything with the code, basically. We're supposed to push another what's it called, branch very soon, because this one we only use the sensorium particulate matter sensor. We use the NO2 SO2 gas sensor. We have temperature, humidity on board. We have the GPS to know the location where the device is going. And then what else do we have? We have noise, to understand, how people are shouting in the environment, basically. But recently, when I mentioned the branch, we're implementing some sort of thermal sensor. So meaning we want to understand because there's heat wave in Europe, there's heat wave in Italy, in every part of like Europe and the US as well. We want to understand the environment based on where is the heat coming from in building. For example, we are deploying this in Stockholm. Stockholm is a very cold place, so there's always a reference to see that there's heat coming from either the surface of the building, because that's always where they install the heater for that apartment. So we are running that pilot pretty soon. The goal is also to, push it out there for anyone to also modify. We're using this MLX sensor, and we're also using some sort of triangulation to make sure that we don't get pictures of, of the government building or something. So yeah, so that is that about, in quotes, one of the very well documented product that I work on, or project that I work on, basically. I'm going to touch base on two more things before we wrap it up. Thanks to Frank for also introducing, showing me one of these other platforms that kind of very, very open, where people can also upload their products and project as well. You can browse project, and what makes this unique is you can put anything, not necessarily hardware. You can put I saw a very funny picture of someone. Yeah, this is it. Someone trying to transport 80 liters of drinking water. It looks cool. People can put any products within this open know-how, and the goal is that you can go to the file, recreate the same thing. They added the file of how you can transport 80 liters of drinking water. So yeah, this is also a very good platform, and Ostra support this a lot. Like, our logo is somewhere. Yeah, it's somewhere here. It's a very perfect tools for anyone building any product. It doesn't have to be hardware. Another important, so if you have questions about this, yeah, I think I've pretty much covered some of these things. Another important part I also want to mention that that was well documented. I was part of the Academy products, like a competition back in 2020? So Academy is also a very good platform where you can update document your product. The good thing is Academy and the Tindy that I shared before. I don't know if they call it Tindai or Tindy, but I usually call it Tindy. It is part of Academy, meaning I think Academy owns Tindy, basically, like the supply chain or supply thing rather. They own both Academy and Tindy. So there's some sort of synergy between these two companies. So Academy is also a very good platform where you can document your products, you can document your projects, and I try to mention that one of my, it's a competition that got selected in 2020 to, sponsored by Conservation X, and they kind of, we try to build a product where we can track fishing. It's around the fishing platform within the water, tracking entangled fishing gear within the water. Fishermen usually face this issue. So can we make it much more easy to track those nets using some sort of IoT tools and LoRa technology? This was, and it has like a lot of views, and this was also well documented. But Akade is a very good platform where you can put your products out there and project out there. The good thing is that there's always contests, meaning Akade is always like pushing out competition where you can get 5K, 20K, 500K to kind of support your product. They usually get DigiKey support as well, where they can kind of send the component to you wherever you are. So pretty much these are things that I think I've covered. Yeah, if you have some very, very like specific question that you want to ask about your hardware designs that you're working on, yeah, please feel free to let me know. Yeah. Okay, I'm going to stop there for a moment. Yeah.
Thank you, Toby. Thank you for this amazing presentation. We do have a few questions in the chat box, if you don't mind.
So I think you'll be better share us links either by email or in the chat to go through this interesting. Yeah, I'm happy to share that. Yeah. And there is one from Dara.
Yeah.
He asked that what would be your advice on someone just starting out in hardware? The learning curve seems to be so steep, and no community to learn seems to be hard to find. Dara, are you in Nigeria? If you are, I think I've been a very yeah, I've been really preaching about how to support hardware. I remember there was a course I kind of give out to everyone. I think that was following me on Twitter, that they can learn how to start their own hardware journey, just watching videos, basically. It's a very interesting procedure, but the community right now, people are just focused on either how to keep their job or how to, make sure they are still doing something impactful. So the time to kind of teach and train people is really limited. But there's always a procedure of one-on-one conversation. If you have questions about how to figure out things about your product or your design, specific hardware questions, I think you should be more than happy to reach out to me as well, or reach out to anyone that you think you might be comfortable with. But again, for hardware products, one of the reasons why I kind of find it difficult to kind of teach is that people come out with questions around coding, which is Arduino coding, but they don't understand the rudiment behind the electronics. So whoever want to build any hardware products, you need to know the zeros and one of electronics, either the basic electronics design, or unless you're just going to burn your first Arduino that you purchase by just plugging in unnecessary voltage within the Arduino. So having the background basic electronics knowledge before going into real, in quotes, hardware design that has microcontroller on board, it is really important you have the understanding of basic electronics. But the community is really, I think what Frank is also doing in Ghana is really good. Fab Lab could also be a good place where you can also collaborate and see people within the community where they've been building stuff, where you can learn from what they're building. You can even join part of the Fab Lab course where you have to pay little money. I don't know how much they're paying now. And then you go through the process of training and you learn a lot. 3D, how to use the tools, how to use a lot of things, basically, aside from the hardware. You learn 3D printing, you learn laser cutting, yeah. So, but individual conversation is also important. If you know someone, reach out to them, ask questions, and the question needs to be specific. You need to kind of do a little bit of research about them. Can they answer you? If yes, I think you should feel free to ask anyone. And Dara, feel free to reach out to me via Twitter or my LinkedIn page as well. Frank also asked a question about certification of OSHA. Is there a standard documentation procedure? If there is, can you walk us through? I think I just did that. What project deemed certifiable by OSHA? I think anything. 3D design, just you did a model and you printed something, you can certify it. So there's no specific hardware that we cannot, that can be within OSHA. So yeah. Someone raised his hand. Fab Academy, yes, Fab Academy. Thanks, Frank. Yeah, Fab Academy. And it's so funny, like the father of Fab Lab is just across me. Like the person that invented Fab Lab, you know, I've met him several times within MIT. So if you have interest for me to also link you up with him, I'm totally happy to do that. Someone raised his hand. You feel free to yeah, okay. I'm gonna go ahead and ask questions. Thanks.
Hello, thank you. Hello. Hello.
Yes, we can hear you. Andrew?
Yes, Andrew from Uganda. I started my hardware repair and electronics some 20 years ago.
Wow.
But the problem was I had no knowledge about documentation. So when I came and learned about open source, I got interested. So got one of the friends who took me via GitHub. So I started trying to document whatever things I work on there later. But now the challenge here is I am having a problem with the 3D printing. That's what I'm still forging out with FabLab.
What do you want to print?
Like I worked on an FM transmitter. I wanted to print some things like PCB boards, printable PCB boards for FM radios.
So what you're saying is that because 3D printing is always plastic somehow, filament. Either
how to use it.
How to use a 3D printer, because you can print an FM radio on top of with a 3D printer. So that needs to be clear. But you can design your FM radio and design a casing for the FM radio and use a 3D printer for the casing, just like an enclosure. So since you're in Uganda, why don't you just maybe go on the internet and look for places that you can 3D print your file. Of course, you have to design something. They need to see your model. They need to see the file that you want to print, basically. And then you can send the file to them and they print it. But most of the mistake people made is that they started, although if they have an estimate of how big the product will be, they can start designing something. But if you don't have an estimate of the size, the dimension, you cannot print anything. You have to wait until the hardware is done, and then you do the dimension before doing the 3D printing or doing any design at all. But you should look within your community in Uganda if there's some sort of maker space or that you can, either pay to use kind of thing. So yeah.
But now, open hardware, which platform do you normally advise to document your people's projects? We use GitHub, Wikifactory.
Yeah, Wikifactory is also a very good platform as well. Thanks for bringing that up. You can also use that. But GitHub looks like much more because if you get it certified with OSHA will still need a link to the complete documentation of your platform, of your design. So either use GitHub for that documentation platform, which is free and also open. It depends. There's a lot of method you can use out there. But I just presented some the easiest one that I think people, within the community have used several times. You can also, the wiki that you mentioned would be a good one for your design. So yeah.
Do we getting satisfied by OSHA? Do we just get a link from them to fill the form, or just by using their license?
So as part of what I try to share before, so within the OSHA certification, there are two different, as you see, you just certify your project, you click on it, and you follow all the procedure here, and that's it. You submit, and you're good to go. So there's no extra link that you have to kind of do. So yeah, but I think
Okay, thanks.
yeah, if you have more further question, you have my email address. I think it's part of this invite. Feel free to reach out to me. Okay.
All right. All
All
right.
right.
Thank you.
My
Welcome.
regards to everyone in Uganda. Any other question?
Nice time.
Okay. Yes, Frank.
Thank you, Toby. So my question is pretty simple, I think. With regards to the OSHA certification, is there a standard documentation procedure? If you have a product or you have a project that you want certified by OSHA, is there a standard procedure? What entails getting certified by OSHA? Not as the process is in getting certified by OSHA, but how would you document a project that you can submit to OSHA for certification? Is there a standard procedure on how to properly document from A to B to C to D, then you submit to OSHA for certification?
So I think maybe there's a part I'm missing, but again, this is the procedure if you want to apply to get certified, like if you want to get your product certified. But you can use whichever method. For example, Andrew also make a reference to Wiki. You can use GitHub as a platform where you put in all your files, like all the designs that you've created for your products before you get it certified. And within the OSHA, there'll always be a link where you put in, you know, where the product is basically. So the project basically, you see project websites, you can just add the link here. And then part of the procedure of OSHA is we just go through the documentation that you've created. It could also be the open know-how platform or the GitHub platform. And then when we go through it, if it's well documented, I think it's going to be accepted within the OSHA. And after being accepted, it goes into list of projects within OSHA. It gets a UUID, as I mentioned before, and this is it shows, it goes into the project listing here, and it gets a UID number, and you can always use this UID to do like a product advert, or anyone. It's certified. No one can just go ahead and do anything, and they want to get it certified as well. So pretty much those are the two categories of documenting your products first, getting the certificates as maybe the second thing. You don't get the certificates before documenting. You understand what I'm saying? And that's why me starting with certification is just to give you like a background knowledge of what OSHA does with certification. And then I go into one of the very important method on how to do like the GitHub documentation as well. Okay. I don't know if I answered your question, Frank.
Yeah, I did put another question in the chat box. I also wanted to, you talked about files.
Yeah.
So I wanted to find out the files needed for documentation, because I'm aware when it comes to documenting projects, we have the bill of materials, the code, if there is one, and you have the assembly processes. So I'm asking if you can walk us through that particular process, because essentially that constitutes the documentation. So I hope you understand my question. Yes.
Yeah, I understand.
Yeah. The second part is, the second part is if you can walk us through open licenses for open hardware projects. You did talk about the MIT open license when it comes to OSHA. Are there also other open licenses that we can use for open hardware projects?
Yeah. So that's a good. So I'll go from the second part. There's about the license basically. So there's there's a part within the OSHWA that shows the hardware licensing. So these are recommended licenses for hardware. You can see the list. For this call, I won't be able to go into one specifically, everything one after the other. But if you read through each of these licenses, you can add it within your certification platform with OSHWA. This is for hardware, basically. And then for software, there's also their own licensing, which is, MIT is one of the very public, method that people use for software. And then it now also looks like they use the same for firmware, because firmware is like a software in disguise that the background is converted to hexadecimal formats that there's no license for that. But you write it in software first before moving into what is programmed into the microprocessor. So, and this is for the software. And these are lists. There's Apache, there's MIT, Mozilla. So you can use any of these license for software. I think for hardware and software, basically. And for documentation, there's also CC BY. These are also a list of 3 other methods that you can use for documenting, for licensing your documentation. If you've written something spectacular that you want it to be a normal Creative Commons license, you can select whichever you prefer. So yeah, I think pretty much those are 3, like you have the hardware, software. The hardware can also fit into the 3D or the design that you've made, and the software can fit into your circuit design, or your PCB layout, or your PCB design, your PCB files. You can also fit into that as well. So that is that about the licenses that you can select. And the first question that I'm asking, that you ask is that I should walk you through. Let me go through the chart again. File needed for documentation. So everything, for example, you want to create an hardware. There's always either use Proteus or you use Altium, or you use like open source GitCard or whatever you've used to design your hardware. You have the file. So, and the file is properly designed. It's working. You have a prototype. Even without a prototype, but you're sure that you've designed something, perfect. You just, either you get the file, the raw file into GitHub, or you convert it. It's always advisable to pull the raw file so that anyone with the same software tools can, remove one of the resistor or change the microcontroller or change the capacitor, basically, because they have access to everything. You can also put the schematic as well. And for the 3D printing parts, which is also very important, you need to put everything, like for the steps, which is the design. You can also put which one you have to laser cut, which one you have to print with the 3D printing, and the materials you need for the printing itself. There's a link here that shows the material, which is, just like an Excel. It gives you access to where you can buy, shows the costs. I don't know if there's MC Master in Africa or some part of Africa, but this is available in the US. You can always, or DigiKey as well, you can buy all the components. So we added the BOM link, like an Excel sheet to the file for components purchase, especially for the 3D printing. We've done the same for hardware as well. So for the firmware, as I mentioned, all these files, if you download these, because you can see we have the library, we have the SRC file. If you download these, you should be able to, within VS Code, you should be able to kind of compile, definitely, if you have all the plugins. So again, if you're going open, you have to go open completely. There's no method of saying you have to hold on to something. Everything needs to be open. Everything, the raw file needs to be there, which is very important. As part of showing that you're very open to the world to use your design or your product, basically. So again, I started with a specific fact. We've all enjoyed the open platform, either open source code. it is really important for us to also give back to this open platform so that someone else can enjoy the same thing we've learned or we've enjoyed in the past that kind of groom us to make us become who we are today. So yeah. Okay, any other question? Frank, I don't know if I answered your question.
Yes, you did. Thank you.
Any other question? You can raise your hand or just unmute and go ahead and ask. But again, feel free to reach out to me via email or via LinkedIn. But if you have a specific product that you also want me to walk you through the process, you want me to sign some sort of NDA of your products, I'm totally happy to kind of share the 20 or 30 minutes to walk you through your hardware design to kind of make it well documented. But again, another skills that is very important for hardware design that we need to all, if you call yourself like a mechanical engineer or electrics engineer, we need to always learn to document everything, either in writing first before putting it in publicly. It has to be documented so that if anyone wants to create the same thing, even within your company, it needs to be documented using Notion to show that you have a bug that you need to fix. You have things you need to fix so that if anyone is going to continue the product, they don't get stuck. They just continue the whole process that you've started. So yeah. Any other question? Okay, I think that is it. Frank, I don't know if you have any other thing to say or kind of announce.
Yeah, I was about to ask if it's okay for me to share your email with everyone.
No, absolutely. I think it's totally fine. Even if you didn't share it, I think somehow if someone Google my name, they will see the email somewhere. So it's totally fine if you can share that.
Okay.
Yeah.
All right. So I'll put that in the chat right now. Yeah, there we go. So anyone has any more questions for Toby? Okay, looks like we have no more questions. Yeah. As we come to the close of this webinar, I want to express my heartfelt gratitude to every one of you. Your presence and your active engagement have made this event a resounding success, demonstrating the power of collaboration and the commitment to open source ideas. I also want to thank Toby. Toby, thank you for being such an amazing speaker and for sharing with us your expertise and your experiences. And as we conclude this event, I encourage each one of us to take the lessons learned today and apply them to our own project. Embrace the responsibility of being a meticulous documenter and an advocate for sharing your innovations with the world, and to always remember that every piece of documentation you create has the potential to empower countless others, sparking innovation and driving positive change. Let's carry this momentum gained here today into our respective communities, our respective networks, and also share the knowledge we've acquired from this webinar and actively contribute to existing open hub.
Frank, you're breaking up a little bit. Yeah.
Can you hear me?
We can hear you now.
Okay, so as we part ways today, let's stay connected and let's continue to foster a sense of camaraderie within the open hardware community. And thank you once again for being a part of this memorable webinar. Together, we have taken another step towards the pursuit of open hardware excellence. I wish you all success in your future endeavors, and I hope to see you again in our future gatherings. So stay curious, stay passionate, and continue documenting the path to progress. Goodbye, and take care, everyone.
All right. Bye. Bye. Bye.